Hi, this is Mr. Miller. Welcome to video 8, Basic Inequalities. Let's do some math. In class, we were working on graphing inequalities. I'm going to practice that a little bit more, and I want to add one more thing, and that is interval notation. So here are 3 different ways to describe intervals. The first one is the inequality itself, x greater than -2. So we learned how to graph this. I'm going to try the best I can to draw this. We put a hollow dot at -2. And since we want numbers greater than -2, we draw an arrow to the right. So all the numbers down to, but not including -2, are in this interval. Now this is something a little bit new. How do we describe this in what's called interval notation? Well, since -2 is not actually part of our graph, I'm going to put an open parentheses, and I'm going to put a -2, and my graph goes on actually towards infinity. It goes all the way to the right on the number line. So I'm going to put an infinity symbol here, and this means, and close the parentheses, this means all the numbers up to are starting at -2, not including -2, and going all the way up to infinity. Okay, let's try again. Here's another one, x greater than or equal to -1. So this time I'm going to use our positive one. This time I'm going to use a solid dot. So let me try to shade in a solid dot there. And its number is greater than 1. So we're going to go to the right. My pen's not totally cooperating here, but we're getting it. Now, I want to describe this in interval notation. Pretty much, it's the set of numbers in between 2 points. Okay, so the first endpoint is 1. And then, again, this is going all the way up to infinity. Infinity is not really a point, but it just means it keeps getting bigger and bigger, and it includes all the numbers greater than 1. So I'm going to put an open parentheses, because technically it doesn't include infinity. Okay, so I use a closed parenthesis. There we go. I use a closed parenthesis when it includes the number, and an open parenthesis when it doesn't. So we'll see this as we do a couple examples. The next one, x less than or equal to 12. So we're going to put a solid dot at 12 because it includes 12. And then we're going to draw an arrow to the left. We want numbers less than or equal to 12. So these numbers go all the way down to -infinity. So when I'm writing the interval notation, I'm going to put an open parentheses, a -infinity, comma, then I'm going to put the upper endpoint, 12. And because it includes 12, I'm going to put a closed bracket. We'll practice a little bit more when we get back to class, but this will give you an idea of what we're going to be doing. All right, the next one, x less than 8, put a hollow dot at 8. And it's less than, so an arrow to the left. There's the graph. Now, it goes down to -infinity. So I'm going to put open parentheses, -infinity, comma. I'm going to put the upper endpoint, 8. And this time using open parentheses because it doesn't include 8. So this interval notation here means all the numbers from -infinity up to, but not including 8. Let's do a couple more examples. Here, we haven't seen this yet in class, but this is something we'll be talking about this week. This one right here. Let me get my pen working again. This is 2 inequalities combined in 1. So this right here means x is greater than -2 and x is less than 2. It means it's kind of in between -6 and 2. So here's -6. A hollow dot at 2, and we're going to draw a line in between them. So it's the numbers in between -6 and 2, but not including them. In interval notation, we're going to use an open parentheses. My left endpoint is -6, my right endpoint is 2, and another open parentheses. Okay, the next one is similar. -1 is less than or equal to x, which is less than or equal to 4. So I'm going to put a solid dot at -1. That's where this interval starts. And we're going draw a line up to negative 4. I'm sorry, positive 4. So it's all numbers in between negative 1 and 4, including the negative 1 and 4. So we're going to use a closed bracket because it includes negative 1. And it's going to go up to 4, and another closed bracket because my interval includes 4. So pretty much when it's a hollow dot, you're going to use an open parentheses, and when it's a solid dot, you're going to use a closed parentheses. All right, these two I'm going to go through kind of quickly. 3, or x is greater than 3, so hollow dot at 3, less than or equal to 15, so solid dot at 15, and connect them. It's the numbers in between. So open parentheses at 3 because it doesn't include 3, and a closed parentheses at 15. Here's one more. X is less than 16, so let's put a hollow dot at 16. Less than means to the left, so it goes all the way down and keeps going and approaches negative infinity. So we're going to do open parentheses, negative infinity, comma, 16. It doesn't include 16, so we're going to put an open parentheses. So there you have 3 different ways: an inequality, a graph, and interval notation for describing an interval of numbers. Okay, I want to review something we talked about in class very quickly. That's the flip rule. So you got to know when you have to reverse the sign of an inequality. So the first one, we're going to multiply both sides of this inequality by 3. And we're going to see if we have to flip the inequality or not. So negative 2 times 3 is negative 6. 5 times 3 is 15. And I see that negative 6 is less than 15, so there was no flip here. The number on the left was smaller in the beginning, and it's smaller in the end. All right, subtract 10 from both sides. So on this side, I would get 17. This side, 33. And it's still less than. So again, when I subtract 10 from both sides, the side that was smaller is still smaller. So there was no flip of the inequality here. This time I'm going to divide both sides by negative 2. Negative 8 divided by negative 2 is 4. 20 divided by negative 2 is negative 10. This time there was a flip. So this time the left side became greater than the right side. So we had to flip the inequality. So when we divide by a negative number, we have to remember to flip the inequality to keep it true. The same as with multiplying by a negative number. We're going to multiply both sides by negative 4. So I get negative 8 on the left, negative 40 on the right, and negative 8 is greater than negative 40. Negative 40 is more negative than negative 8. So again, we had to flip. In order to keep this true, we had to flip the inequality. Okay, so the rule is when you're solving an inequality, if you multiply or divide by a negative, you have to flip the inequality. So we're going to apply this to 4 quick examples, and then I'll have your journal assignment. So here we have an inequality, and we want to keep it an inequality. Sometimes students change these into equations, but it's not an equation. So if we start with an inequality, that's what we're going to finish with. But the method of solving is almost the same. Add 41 to both sides, and I get 4x is less than, that's 136. And if I divide both sides by 4, I don't have to flip because I'm dividing by a positive number. I get x is less than, let me see here, 34. X is less than 34. I had to use my calculator in there. Okay, that's the solution to our inequality. All numbers less than 34 work. So if the number line isn't labeled, just put a 34 here somewhere. Put a number on the right, maybe a number on the left, and this is going to be a hollow dot, and we're going to go to the left. In interval notation, this means that any number from negative infinity up to 34 is a solution to our inequality. So usually you're asked to give a graph for an inequality, and we're going to practice our interval notation too. All right, next example. We're going to start this the way we would normally start. We're going to subtract 126 from both sides. And we get negative 3x is greater than or equal to something. Let me see. 39 minus 126 is negative 87. Okay, so divide by negative 3. And we're dividing by a negative number, so we're going to have to flip. This is going to be x less than or equal to, so I flipped. Negative 27 divided by negative 3 is positive 29. So let's label 29 another number or two. Is kind of a generic number line, so that's why we have to number it. We need a solid dot, and less than means we're going to go to the left. Okay, for interval notation, negative infinity up to and including 29, so a square bracket. There we go. We have it 3 different ways. I gave you a simplified inequality, a graph, and an interval notation. 2 more examples, and we're done. Here we go. So let's start here. We're going to add 4 to both sides, and it looks like we're going to have to multiply. So plus 4 on the left, plus 4 on the right. We get x over 17 is greater than 14. So remember, we're dividing by 17, so we're going to multiply both sides by 17. On the left, we'll just have x, and on the right, we're going to have whatever 14 times 17 is, 238. No problem. So we'll put a 238 on the number line. I'll put a 237 next to it. Not a lot of room here. I'll put a 239 to the right, and a hollow dot at 238 and an arrow to the right. So interval notation, open parentheses, 238 to infinity. You pick any number in between 200 or greater than 238, it'll work in the inequality. All right, our last example. So this one involves distributing. So our steps for solving are pretty much almost identical to equations. We just got to remember we have to flip the inequalities sometimes. So I distributed. Now I'm going to simplify. And now subtract 6 from both sides. And got to flip. We're dividing by a negative. So divided by negative 2, I get x less than or equal to negative 15. Okay, so put negative 15 here. This tricks people out sometimes. The number that's smaller than negative 15 is negative 16. And then negative 14 is greater than negative 15. So sometimes when it's negative, people get a lot confused. But remember, more negatives are to the left, less negatives are to the right. So we have a solid dot here. And then we can draw our arrow to the left. And this is going to go from negative infinity up to and including negative 15. Okay, so a couple new things here. Other things we talked about in class, and we're going to practice it the next time we're together. So I have 4 problems for your journal assignment today. Please copy these and solve them, and then add a basic graph. So just draw a basic number line and add a graph for each problem. All right, see you in class. Good luck with this.